Sometimes you can model a real situation with a system of linear inequalities. Solutions to real-world problems are often whole numbers, so only certain points in the region of overlap will solve the problem. Problem 3. Using a system of inequalities. Fundraising. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? First, consider what you know. You know they must raise at least $30,000, and you know there are at most 500 orchestra seats available. Next, consider what you need. You need the possible sales of balcony and orchestra seats. And so your plan: model the problem with a system of inequalities. Graph the inequalities on your calculator. First, we'll relate the quantities. 20 times balcony seats plus 30 times orchestra seats must be greater than or equal to 30,000. We also know orchestra seats must be less than or equal to 500. We'll define variables. We can let x equal the number of balcony seats sold and y equal the number of orchestra seats sold. And now we can write the system of inequalities. 20 times x plus 30 times y is greater than or equal to 30,000, and our second inequality, y is less than or equal to 500. Now we'll rewrite 20x plus 30y is greater than or equal to 30,000 in slope-intercept form. It becomes y is greater than or equal to negative 2/3 x plus 1,000. So our system of inequalities, in its simplest form, y is greater than or equal to negative 2/3 x plus 1,000, and y is less than or equal to 500. Next, we'll use our graphing calculator, or Desmos, to graph the inequalities. The solution is the overlap of the two half planes. Now, it's a good idea to test a point. We'll choose a point in the overlap region and test it in both inequalities to see if it satisfies them both. Here the test point is 900, 450, so 900 for x, 450 for y, and so we'll plug that into both inequalities and ensure that it satisfies both. On the left, 20 times 900 plus 30 times 450, is that greater than or equal to 30,000? Simplifying, we find that it is. And on the right-hand side, for our second inequality, is it true that 450 is less than or equal to 500? And sure enough, that's true as well. So our test point checks out, which is a good indicator that we've graphed correctly. Because the number of seats must be a whole number, only the points in the overlap that represent whole numbers are solutions. Your turn. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza?